For this video, we're going to be revisiting triangle congruence, and this time we're going to talk about some of our shortcuts for determining if two triangles are congruent. So here you'll see that you have triangle ABC is congruent to triangle DEF, and what you are given is each of the corresponding angles are congruent and each of the corresponding sides are congruent. So what I'm going to be talking about in this video is that you actually don't have to have every single piece of that information in order to be sure that two triangles are congruent. Before we go too far into this, I need to talk about some terminology I'm going to be using. That is, this first one is an included side and an included angle. Now what I mean by included means that it is between two things. So if I talk about an included side, I'm talking about a side that is between two angles. All right, the example would be side BC, right here, is in the included side between angle B and angle C. All right, the included angle is the angle that's between two sides. In this case, angle A is the included angle between AB and AC. So I'm going to be using those terms. So let's look at our first shortcut for proving that two triangles are congruent. This is the side, side, side postulate. All right, so these are proofs. All right, these are things that we know to be true. The side, 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 or SSS congruence postulate says if three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. Okay, so even if you are not told that the angles are congruent, if you know that these sides are congruent, if you know that LM is congruent to OP, if you know that LN is congruent to PR, and if you know that MN is congruent to OR, you can be 100% sure that the two triangles are congruent, even if they didn't give you the information about the angles. So this is a shortcut. We can prove two triangles are congruent if we know three sides. Okay, there's an example of the side, side, side postulate. Now, what about the side angle side postulate? If two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. So here's the example. Side angle side, if we know that LM is congruent to OP and that angle M is congruent to angle O and that side MN is congruent to side OR, we have to be able to say that the two triangles are congruent. Now, what that means is that no matter what I tried to do here, I would always have to draw the same line at LN and PR. I would never be able to make a different triangle. So if you know two sides and the included angle, so again, that is the angle between the two sides, then you know that the two triangles must be congruent. Look, and here's another example. It doesn't have to be the one in the corner. You can also have the information move around the triangle. Okay, the angle side angle congruence postulate. If two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, then the two triangles are congruent. So here's our example of the angle side angle theorem. You see that we know angle L is congruent to angle P. We know that LM is congruent to OP, and we know that M is congruent to O. This is enough information to determine that two triangles are in fact congruent. This is the angle side angle postulate, and you see it can move around. Okay, so this is on the other side. This time we know the different angles and sides are congruent. And there's another example. We also have the angle-angle side congruence theorem. If two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of a second triangle, then the two triangles are congruent. Here's your example. Here's your angle side. If we know the angle side, if the corresponding angles and sides are congruent, then the two triangles must be congruent. You would never be able to draw a different line here to be able to create any other triangle. If you have those two angles and that side, angle, side, notice that it's in the order. Angle with side at the end, meaning that side is not the included side, it's the non-included side. Then you can determine that two triangles are in fact congruent. There's another example of angle side, and there's angle side again, and one more, and another one. So you can see that there's a lot of examples of angle side. You just got to make sure that you pay attention. So I'm just going to give you one quick example, explain why the two triangles are congruent. I have my angle, they have a shared side, so that's congruent, and another angle. This side is the included angle, so the side would have to be in the middle. This would be angle side, angle C. So now go answer your questions. Make sure you submit this Google form and click Mark as done when you're done.